Dr. Oldall please come up to the stage and give him a round of applause? Hello, you ready?
Yes.
Okay, so floor is yours.
I think I have to, okay.
Oops, sorry, technical issues. Cool. All right, sorry.
Okay, thank you. Yeah, hi, nice to meet you. I'm Georg Urtel from xFOREST Therapeutics, and I'm here to talk to you about drugging the undruggable by targeting RNA. And I want to start by explaining to you what I mean if I say something is undruggable. In the human genome, there are more than 5,000 disease-related genes. However, only a small fraction of this has actually been drugged on the protein level with conventional methods. The majority is actually considered to be undruggable with such methods. So that means we need new methods. And one option is to target RNA with small molecules to address these diseases. This has, if we want to look at the target gene, we're not going to try to target the undruggable protein, but we go one step upstream and we focus on the RNA. And this has actually been done successfully by a drug called HVC, which is a splice site modulator for the treatment of spinal muscular atrophy. And it was found in a phenotypic screening, and it has been successfully on the market since 2024, and it became a blockbuster drug. However, there are no other drugs like HVC. And if you try to find such a drug in a target-based screening, the field suffers from low hit rates, so it's just not easy to do this. And to overcome these problems using conventional methods is also not an easy task. There are two solutions in the field, and one is you just increase the screening size. But obviously this is slow and it is expensive. Another option is you exchange the library, so you use small molecules which are very, very likely to bind to RNA, and with conventional methods you might find hits, but later on you will suffer from poor drug likeness and unselective bindings. What we are doing is a massively parallel but cost-effective screening, and the data we get enables SAR with information on selectivity and single nucleotide information. And the reason why this cannot just be emulated is, of course, we have a lot of know-how, but also we have good IP protection. But now I gave a lot of promise what our screening can do. I should also explain how we can do this. What we have is a platform called xFOREST, and it's an all-combination profiling of RNA structure libraries versus compound libraries. We start with thousands of RNA motifs in a single tube, and we dispense these RNA motifs into a reaction plate. To each well of this reaction plate, we add different small molecule compounds, and the small molecules and the RNA motifs can react freely in solution. The readout we use is NGS analysis, and what we create are large-scale mutational profiling big data sets which contain binding information on all RNA motifs against all compounds. I want to highlight that besides getting up to 1 billion combinations, we get additional information. If we have a hit compound, we get information on the selectivity. We can see, is this hit compound binding to one RNA motif, or is it binding to all the RNA motifs in the library? We can also see the secondary structure of each RNA motif in our library, and we can see which nucleotides are important for the interaction with the hit compound. And what we find are selective binders with excellent affinity. And I want to highlight especially those two parts because this is typically what you obtain only in later stages, but it gives us a head start into the SAR process. And most of this data cannot be acquired by competitors, and yeah, especially not on such a scale. I want to showcase with a collaboration study which is still ongoing what we can achieve. So in this case, we start with a target selection process. So we go through the transcriptome, we select druggable motifs, and we synthesize the RNA library. So with this library, which typically contains thousands of RNA motifs, we go into the screening, and yeah, what we find are over 20 selective hit compounds in this case, and we could explore the chemical space for drug-like RNA binders. And the time it takes from starting this analysis until we have the validated hits is around half a year. We are currently in this project in the hit to lead phase, and what we have now is a sub-micromolar small molecule binder, which is not a singleton, so we can see we can develop it, and we have cellular function for our target, so we have a knockdown in the cell. And to summarize this slide, this is really good data, this is really good results, and our client is really happy about it. But this is not our only client. In Japan, we collaborate with the biggest pharmaceutical companies such as Takeda, Daiichi Sankyo, Kyowa Kirin, and Otsuka, and all of those projects are still ongoing. And we are also very happy that earlier this year we reached our first milestone with our launch customer, Takeda, so it shows that we can also deliver on our promises. So up until now, we really perfected the use of this xFOREST platform. We increased the throughput from doing experiment essentially by hand in 2020 to tens of thousands of plates at the current state, tens of thousands of compounds per day at the current state. Later this year, we want to introduce another high throughput screening platform, which is based on a in vitro splicing assay. So this will really complement what we can do. We want to use the data we collect now for machine learning purposes, and we want to introduce new services to our product portfolio. And at HVC, we're looking to learn about pharmaceutical companies' needs, and yesterday was already a good start. I'm looking forward to the Q&A session, but before that, I want to quickly mention our team. I put it in the end because I always run out of time. So the company is a brainchild of Shunichi and Kaoru, and me and Shenya, we joined as a co-founding members, and we were responsible for this increase in the throughput. Ken and Yuko are our business developers, and so all four of us are here, and I have to learn a lot now from Ken and Yuko about business development, so please consider this in the Q&A part. Yeah, thank you for your attention.
Thank you so much, Dr. Ota.